My name is John Hengeveld. I'm a Director of Software Product Management at Intel. I have one of the coolest jobs in the world, but I can't tell you about it. I'm also the chair of the Privileged Software Horizontal Committee, Vice Chair of the Privileged Software Horizontal. The chair is over there somewhere. There he is, Aaron, for RISC-V International. I am presenting a panel of really cool minds and interesting people to talk about the subject of building a scalable RISC-V ecosystem. There are two words I want to focus on in there, which is the word scalable and the word ecosystem. So scalable is the first time you do something, it takes a certain amount of input. Subsequent times, it takes less and less and less. So that the more energy you put in after a time produces greater results than the energy you're putting in. So that's one challenge in building an ecosystem. And the second challenge in building an ecosystem is software. So I want to talk today about the gaps in the software ecosystem, where they fall, how to address them, and what we can do as a community to make things go better. I have a terrific panel up here. I'm really excited to hear from these guys. And forgive me if I butcher any of your names, which I'm likely to. Kumar is Vice President of Software and Solutions from Ventana. Leendert is Senior Vice President of Technology from Qualcomm. You want to raise your hand and say hi? Steve, I can handle that one, is a business strategist from Linux, on Linux from Red Hat. Olivier, I've known for many years, IoT and robotic services from AWS. And Makeljana, operations and growth strategy from VRULL.
Hi.
This is a bright, interesting panel, and we're going to work this in two parts. First is I have a collection of questions I'm going to ask these fine people, get them warmed up and started, and then I hope we'll have a fair amount of time for Q&A at the end, and be thinking about questions as you go through this. If we have questions online, if they're relevant, and we'll pull them in. If you have a question in response to something that they say controversial, and they will say some things controversial, feel free to raise your hand, and we'll try and take them at a time, but let's see if we can get through the prepared material before we dive into the Q&A. So, what I'd like you each to do on the first pass, introduce yourself, your company, if we don't know who your company is. Some of you don't have to say much about your company. And my question to you is, what would make RISC-V a success for you, specifically? What's the win for you in this? And let's start with that. So we'll go left to right. Kumar, if you want to jump in first, introduce yourself, what you do, and what your company is, and that.
Yeah, thanks. Can everybody hear me? Yeah. Thanks, John, first of all, for having me on the panel. And my name is Kumar Sankaran, and I'm the Vice President of Software and Solutions at Ventana Microsystems. And my role there is pretty much owning the software organization, owning the platform engineering organization as well, and also drive the RISC-V ecosystem. And prior to Ventana, I was with Applied Micro, where we built the world's first 64-bit ARM server chip, and I was part of the ecosystem there as well. So, pretty much taking ARM 64 ecosystem from inception all the way to production, right? So that took a good 5 to 6 years, and then now we have so many of these ARM 64 solutions in production. So that was my role there. And then after that, I briefly moved to Marvell, where I was there for a few years, again doing 64-bit ARM with their ThunderX family of products, driving the ecosystem, driving solutions as well. Right, so primarily been in the ecosystem, know what needs to be done, some of the scalable aspects of what John was mentioning earlier, been through that. And yeah, so that's been my background. And now here at Ventana, pretty much doing the same thing now, moving from ARM 64 to RISC-V, and being part of this journey here. Moving to the second part of what John asked for, so in terms of what's success for Ventana, right? So what we see is we want to see RISC as RISC-V as the chosen architecture for the next generation platforms, right? So we announced our first generation Ventana Veyron V1 this morning. You guys would have seen that. That's the first generation product we introduced. We are seriously into RISC-V. We see RISC-V as the next market, the next big thing for the market in terms of software. And given RISC-V, it's open architecture, the large software ecosystem. There are over 3,000 people in the community today, 3,000 members, over 10,000 software engineers, right, building the software ecosystem for ARM itself. And the ability for
RISC-V
the architecture.
that time.
I'm sorry?
RISC-V, that's
That's fine. Yeah, and then the ability for the architecture itself to have custom instructions, right? And then domain-specific acceleration that lends the architecture to be more scalable and also promotes domain-specific architecture. So that's what we are promoting as a company, as Ventana, that we want domain-specific accelerator-based solutions. And that's, with the chiplet architecture that we are promoting, we feel that that's a right fit for the next generation compute requirements that the data center is kind of putting on us, right? So we are invested in this. We see a good future with RISC-V, and we have a very good fit with the Veyron V1 product family.
Thanks a lot. Congratulations on your announcement, by the way. Leendert.
So yes, I'm Leendert van Doorn. I'm at Qualcomm, where I'm responsible for software strategy, and I also own the AI Software Organization, which is a worldwide organization responsible for all Qualcomm's products and the AI software stack for it. Since Kumar brought up ARM, we have been working together in the past. I've been responsible at Microsoft Azure for getting ARM servers into Azure and standing that up, probably something that my Intel brethren over there don't enjoy that
XARM,
much.
so I'm okay with it.
Oh, okay, XARM, okay. So as part of that, obviously a lot of the ecosystem bring up that we did there. And so I see a lot of parallels with where RISC-V is now from where ARM server was 7-8 years ago. So that's pretty cool to see. So, but we'll probably talk about that a little bit later into this whole Q&A. So let me quickly go down to what my success criteria is. Well, from a Qualcomm perspective, I'm looking at RISC-V, not just from a hardware, but also from a software solution, and where it can meet all our product requirements across the entire portfolio, right? This means anywhere from microcontrollers, which we're already doing, and you saw this morning that we already deployed 650 million of them since 2019, but also all our APs, right? What goes into anything from wearables to anything from data center and anything in between. So that's my success criteria.
Good afternoon.
Thank you.
Yes, thank you. Good afternoon. My name's Steve Wanless, and I'm here representing Red Hat Software, a small open source software
If you could move the
organization.
mic just a hair closer to your mouth.
A little closer to my mouth? Okay. I'm here representing Red Hat, a small software organization with a focus on open source software. Thank you. Prior to Red Hat, I spent 20 years at Dell, working on all kinds of hardware and open source software on top of that. So I guess I'm coming at this with both a software and a hardware point of view. And I guess my answer to the question, what makes RISC-V a success, to me, rapid adoption. Rapid adoption driving volume, rapid adoption with as minimal ripples to the software ecosystem that we currently have as possible. So if you're a RISC-V vendor looking to run data center workloads, you're not going to see SAP HANA running on RISC-V as an execution engine if you make a huge number of changes to the runtime environment that's out there at the moment. So.
Thank you. Olivier?
Good afternoon, everyone. My name is Olivier Bernard. I'm a principal at AWS, and I lead our go-to-market strategies for our AWS IoT services. Now, for those of you guys who are not familiar with AWS IoT services, because I'm assuming you all know who AWS is, we have a whole range of services that runs on IoT devices, and that starts with FreeRTOS and Amazon Linux, but it builds with a complete suite of product and services on top of that to do device management, device orchestration, device security, data management, IoT core, and then on top of that, application management. So Amazon as an organization, we're a company that builds stuff at scale. We move things at scales. And so when you talk about what success looks to us, success, and it's a challenge for every one of you in this room, success to us is 1 billion devices built on RISC architectures connecting to our cloud. That's the challenge. Now, how do we do that? We already have success stories. We already have commercially deployed RISC-V devices from some of our partners that we're shipping and we're managing on our cloud. So that's real today. It exists. What we need now is more choices and more devices and more applications, because with the services we have, with the scales we have processes to onboard RISC-V devices anytime they're ready to ship.
Makeljana?
Hi, everybody. My name is Makeljana Shkuti from VRULL. I am responsible for the operations and growth strategy at VRULL. For those of you that haven't heard of us yet, we are a software engineering company offering consultancy to semiconductor companies, but also device manufacturers. We work, basically we have our hands in everything that's software, but in the last couple of years we've had our hands mostly on emulators, tool chains, libraries, Linux kernels, as this is where the necessity has been. About myself, I am the freshest blood actually in the industry. I've joined just 2 years ago, and I find a lot of potential, not just for what we're doing, but also for myself to grow, and I'm actually very happy to be part of you all. What success looks like to us when it comes to RISC-V? I guess our colleagues here said most of it, but I would just say for RISC-V to be up there, to be everywhere, and also to be the choice next to x86 and ARM, and most importantly, to be the first choice when it comes to innovation.
Beautiful. So my turn to make a quick plug. I work for Intel, and what my job is to actually help enable our Intel Foundry Services operation to serve customers better by having software available to help them be successful. So I'm really passionate that RISC-V and x86 and ARM live together in an ecosystem, all solving different problems. And the more people can bring their business to IFS to build wafers for them based on technology that Intel can offer and support, that's a better world for us. So part of what I see is that the hardware world is moving along nicely in the RISC-V space. It's picking up, it's accelerating a little bit. So my next question for you guys is this. Do you see gaps in the way that the software ecosystem is moving forward? And if so, how? You want to reverse the order or go the same way?
Your choice.
You next.
Okay, I can go first, yeah. Now, in terms of, from the Ventana perspective, I'll answer from the data center perspective because that's where we're kind of focused on. And then we also target the parallel markets like automotive and 5G edge and client as well. But I'll answer from the data center perspective. So what we have done from the Ventana side is enable all the base framework that is needed from a Linux point of view. What I mean by that is applications that go with Linux, including the BIOS, the full stack of the software, right? So starting with the BIOS, on top of that, there is the operating system, which is Linux. And then on top of Linux is typically a virtualizer environment, which could be KVM-based hypervisor or any other hypervisor. And then there are these middleware that run on top. And finally, the application stack, right? So we have enabled all of these from a baseline perspective so that we can have all these verticals that are available today in existing distros or in upstream Linux. To take a simple example, right? Let's take the example of a BIOS. EDK 2.1 is a standard BIOS which is based on UEFI. We have made that available. We have taken specific verticals. Linux is available, as you guys all know, right? Linux has always been available for RISC-V. The support has been there for quite a few years. And then specific verticals. Let's take storage. If you look at Ceph, we have enabled Ceph. If you look at networking, load balancer applications that run with Nginx. OVS DPDK, something that you would use with a SmartNIC, right? So I just did a demo this afternoon at the Expo Hall where we were showing OVS DPDK, right, as a full solution. So we have enabled these verticals from a full stack perspective. So from a baseline software availability and the readiness for deployment, it's all available. So we don't think from the data center perspective that software is really stopping progress of the ecosystem is what we feel. Yeah.
So are you in alignment with the Wanless proposition that all things should look the same, more or less, as they did before in order to accelerate adoption?
Absolutely, yes. Yes, I'm a strong believer of that. It should, for the lack of a better word, it should just work, right? It has, the way it has worked in the past with x86 or ARM64, the software stack should just work, right? And that's what we are trying to get at. It should be exactly the same as what it was before. No changes. You just run an existing distro, existing application, and it should just work.
Perfect. Leendert?
Thanks. So, yeah, so to me, it's not just software. It's actually the entire hardware system and software ecosystem that needs to mature together. right? So for example, I'm actually quite encouraged to see at this point the definition of profiles, because the amount of instruction set and combinations you can make is actually leads to a lot of fragmentation, right? As a software company, it's really hard to support that. So profiles, I think, are going to bring some order to that. The other thing is, too, is really important to get the basics right. I've seen this over and over again with other instruction sets, right? Make sure you get your atomics right. Make sure you get your memory semantics right. All boring stuff, right? But it's very impactful to software developers. The other thing that's important to realize, too, that first ISA that will come out, you're going to be stuck with that for a long, long time to come, right? And I can refer to ARM again. Yeah, ARM at this point is at its 8.7 definition. The reality is most software is still 8.0, right? And that ISA has some warts, right? So I would highly encourage this whole community is like, let's make sure we fix that. And then when we pick a profile, right, get it as clean as possible as we can, because we will be stuck with it for a long time. It isn't just the ISA, right? It is also about defining a consistent rest of system IP. Right? You're not going to differentiate your product by implementing some unique interrupt controller or your own I/O MMU, right? This only causes actually a lot of support burden on yourself, right? Because you now have to support the software, the Linux patches, whatever other OS you want to run. So again, standardize that, right? This is not where you're differentiating. And then to the point that Kumar made, right, adopt applicable standards, right? If you go into the embedded space, clearly use U-boot. If you go into the server space, adopt UEFI, adopt ACPI, right? These are the standards that are being used there. This is what people have built their tooling around. This is what people are familiar with, right? Anything you're trying to do different there, right, you're going to find yourself a hurdle to get over it. So you already got a big hurdle. Introducing a new ISA is a very, very difficult task, and it will take a long time, right? And we can talk a little bit later about some of the parameters around it. But don't make it more difficult for yourself than it already is, right? So stick to the standards in the environments that you're targeting.
So we have the Wanless proposition, which is make everything look alike from the software up. And we have the Doorn proposition, which is make everything look alike from the system IP down to the standards.
It is all about the platform, right? As a customer, you care about the platform. You don't care about the ISA. You don't care about the individual IP blocks. You care about the whole platform and the value of that platform coming together.
Beautiful. Steve?
So far, I'm a big supporter of the Wanless proposition. And
I think it should be named that way, and there's people writing it down should write about it.
what I would say is that everything that I've heard so far, I would agree with. What I would say is that fragmentation is the enemy of it just works. And earlier today, I heard one of the speakers talk about commodity operating systems. And what he meant by that was, we just go buy it and it just works. I'm here to tell you there's no such thing. Every operating system that just works because there's been a team of people laboriously loving and crafting the low-level components of that operating system where it meets the hardware to make it just work. It doesn't just work straight out of the box. It needs a lot of love and care before it's up and running and reliable. So fragmentation is the enemy of that. And what I would say right now is, let's not go in the direction that other instruction set architectures have done and define a myriad of t-shirt sizes for every little application or every little usage model of where the silicon's actually going to be found. If we're going to do anything, let's adhere to the standards. Yes, let's adhere to UEFI, ACPI for the systems that it's appropriate to. Let's define what it means to have a data center server. Let's define what it means to have an embedded device. Let's start off with those two and perhaps use different standards, as I've just said, ACPI, for instance, inside of a data center server or device tree, perhaps. It's not really a standard, but I guess it's getting there for embedded devices. And let's focus on getting those things right before we start adding more and more t-shirt sizes into the work that we're all going to do, because it is an ecosystem. And one of the things that Kumar said that worried me a little about innovation inside of the RISC-V environment, standards are not your enemy. Standards absolutely are the right thing to build the platform for you to innovate on. If you add instructions into the instruction set, that comes with a price to the ecosystem, because that now drives changes to compilers to actually generate the binary for that new instruction. It generates a need to rebuild libraries. It generates a need for debugging tools around applications that are going to use that new instruction. And so innovate, but innovate with care at that level, because it's going to generate huge ripples inside of that software ecosystem that we're all looking to try and replicate in order to drive what I said initially as my definition of success is rapid adoption. And the more it's different, the less rapid will be.
So I want to stick a pin in everybody in their mind, stick a pin in that notion, and I want to come back to that as a Q&A topic when we get to it. Thank you.
That's a really important point that Steve brought up. I agree 100%. That's probably because I'm on the application side. But at Amazon, we like to talk about the flywheel, which people will refer to the chicken of the egg problem. But we are already at the point where we built a baseline for the ecosystem. So building is done. Now we need to scale and create that flywheel where we build, we scale, more people will build the silicon, more software will be deployed, and then you're starting to spin and you grow the market and you get penetration. So fragmentation, changing ISA, is one of those things that slows down the wheel of spinning. Standards is what make adoption and scalability go on. So that's really, really important. Now, on top of that, once you've built something, you need to repeat it, and you need to put processes around it so that others can build on the same system. So I think what's really important is not only to start building stuff, but also teaching others how to port and build. And to your point, our teams at AWS have spent a lot of love and tendering to make sure that FreeRTOS works properly on RISC-V instruction set. And around that, we've put reference designs, and we put certification programs that teach you how to do this. So what I'm asking the industry is, have a leap of faith. The software is here. We've built the first iterations. Now let's get the wheel working, wheel turning, and let's scale across multiple SoCs and multiple devices and applications.
Beautiful. Makeljana?
So I have to say that I don't have the deep knowledge that all colleagues share here, but I would like to approach this more from a business perspective. We are a software engineering company, and one of we see the challenges daily with our customers and the way that we're trying to approach the entire development or maturing the ecosystem, and we find that it is important that everybody works together in order to push the effort forward. So the question I would actually have is, just putting it very simply, does hardware work without software? Generally, because we do face the challenge that there is some resistance sometimes in the community that not everybody agrees that the software has to be ready in order to be for RISC-V to be considered ready. So with that in mind, answering to those resistance, I would say, if we look out there and we just look at the other solutions and alternatives that are out there. Is their software mature to be adopted, or is there any work to be done before making a decision? Usually, if we're talking about innovation, we are talking about technology. Companies are run by business people, and these business people need to. So basically, the decision is driven by factors like cost, like risk, like timeline, and knowing that the software within RISC-V is not really ready to be adopted. Does this make the decision harder, or does this take? So basically, how easy will it be for businesses to say, okay, we're taking the leap, and we're switching for RISC-V instead of just going with the already existing solution. So these are usually the challenges that we acknowledge and also ask ourselves within VRULL.
That's a terrific point. So let me build on that just a little bit. So one of the key things I think we get out of this is one of the key differentiators of RISC-V is its flexibility. Everybody agree to that? Flexibility, good. But the challenge for the ecosystem right now is how do you take that flexibility and deploy it into specific segments where we can grow solutions quickly? So a big part of what both Leendert, what everybody here is saying is software can help us move forward in a specific area if we focus on it. If we take and do the necessary differentiation for that piece, whether deeply embedded or infrastructure or IoT applications or whatever. So the question I have for you guys is, as one community, where should we focus? Where are the applications that are going to come up first? They're going to drive RISC-V up the curve from embryonic to really deploying and leveraging sufficiently scalable. I'm going to reverse direction, just to be fair once. Give her more good points to build on. So we're going to start over there.
Sorry, what was the question?
What applications?
Yeah, applications, right.
Right. Do you see as the ones we should focus on as a community?
Well, I think it depends who you ask. But if what we have seen or what we see as VRULL, I would say we should expect HPC, AI, and data centers. HPC. So we would say HPC because the HPC developers have the flexibility of basically building silicon around their applications, and what they're looking for is high performance. AI, they have the design freedom to choose accelerators, and data centers because it's already here, we're ready. Emerging applications, we would be looking at mobile and client platforms like desktops, but we can all agree that the struggle there is still ahead of us because the software complexity is big.
Beautiful. Thank you.
So I'm going to be biased, even though I'm a cloud guy from AWS. I'm going to say IoT. And that's because, one, from a technical standpoint, RISC-V is already very well deployed into deeply embedded subsystems. So the leap to go from an embedded subsystem to being exposed to the software stack and the operating system is not that big of a jump. It's not a big change in manufacturing process, nodes that you want to use, packaging. So it's a natural evolution. I will add to this the AIoT, so artificial intelligence of IoT, because that's where you have the most chances to differentiate, leverage all the extension that you have with RISC-V, and come up with something that the incumbent in the architecture, in the industry, is going to have more difficulties to move, just because they have such a large ecosystem, and they cannot just move quickly and bring the whole ecosystem with them. So where you can innovate the fastest and differentiate the fastest, while leveraging the success you already have in RISC-V, is, I think, where we should focus on.
Thanks. Steve?
It's a difficult question because I don't think we know the workloads that RISC-V is going to be optimized for yet. If you'd have said to me 7 years ago, what do you think about machine learning at the edge? I'd have looked at you like you'd grown another head. I wouldn't necessarily have known what you were talking about. But if you said to me, We're talking about distributed high-performance computing using a huge amount of number crunching to train the behavior of applications that are going to interact with the real world. I would have understood that, I think, at that point. So I don't think we know yet. And if I ask the question, RISC-V, an instruction set, what is it good for? We probably don't know the answer to that question yet either. Where is it going to be used? So to some extent, we've got to look at the legacy of the workloads that we're already seeing in AWS. For example, if I look at AWS and I think to myself, what workloads are being run inside of all those AWS instances on top of other instruction set architectures? It's what I would call new age workloads. It's the artificial intelligence style machine learning kind of workloads. It's the embedded workloads that we'll see at the edge. But is that what RISC-V is good for? I don't think so. I think RISC-V is going to be an immense player in the data center compute industries, and they don't change a whole deal, or they don't change particularly quickly. So I think the challenge that we've got in front of us is, how do you continue to support legacy that hardly ever changes? I mean, when I go back and I look at my days inside of digital equipment, looking at VAX machines running various different applications, a lot of those applications really haven't changed a great deal in all that time. So the challenge in front of us is, how do we continue to maintain that legacy that is still absorbing huge amounts of IT spend, while at the same time enabling the flexibility to adopt what I guess I'd call new age workloads, which is where the flexibility of RISC-V comes in. That, to me, I think, is the challenge from the workload side of things that we have right now.
Perfect.
Okay, so I'm going to expand a little bit on what you said, Steve, and probably be controversial. It doesn't really matter what the ISA is from a software perspective. So there is nothing unique about RISC-V that's going to compel certain applications. All ASAs are very similar in that sense. What is the question, though, is what is the value proposition you create with your entire system, right? That means around, can you do a higher rate of innovation? Can you get better performance and power, right? Can you bring your cost down? This is what's going to compel software developers to go to a new architecture. This is what ARM did in AWS, right? Why was ARM in AWS interesting? Because they provided a 40% better TCO. Part of it came out of power, part of it came out of cost. That compelled people to move to a different ISA. It's not the ISA itself. It doesn't matter, right? So now, obviously, there is a set of applications that are better suited to move to RISC-V than others. And these are typically the born in the cloud, the new kind of applications, because you need to develop for it anyway. So rather than starting with a lot of legacy cruft, right, you can start afresh. So that's where, and these are clearly things like containers, IoT, a lot of AI, ML workloads, right? These are all newly written workloads, clearly very suitable. But even there, we need to be quite careful, because there is a long tail of software. Even if you run containers, typically what you run in there, right, is the same standard libraries that have been around for 30 years, right? It's going to be that same math library that you need to get ported and optimized for RISC-V. It's going to be that same HTML library that has been now around forever, right? So, and then there's going to be bits and pieces that you can't move because you don't have the source code for it anymore, you lost it, right? And that's a very real problem too. So technologies like binary translation, we should very actively explore, right? And not only just the translation part of it, but also think about, hey, what is it that we can optimize in the RISC-V instruction set so we can have more, so think of it as translation support assist kind of instructions. But these are all kind of technologies that we need to start looking at. But in the end, it comes down to the value of the entire platform that's going to move software over. And if we get that right, then anything can move.
Kumar?
Yeah, I think I sort of agree with what Leendert said to a large extent, right? So in terms of workloads that would benefit from RISC-V, there are quite a few of them. Some of them are not identified yet. The clear benefit for workloads is not yet known for RISC-V, right? But the important thing is, as you port software from one architecture to the other, the one important thing for this porting activity is what can be moved to RISC-V and be made available in the shortest possible time, right? What can be made available in production in the shortest possible time, right? So if we were to double click on the data center aspect a little bit more, one of the key things is storage, right? Storage is the lift to move applications in the storage sector from one architecture to the other is minimal. I think Leendert probably would agree with me on that, right? So that's what you would typically tend as the first workload to deploy or move over or cut over to RISC-V. Now, the web tier is the second one, right? Where things like basic web servers, caching servers, content delivery networking. Right? These are areas where, again, the lift to move software from one architecture to the other is not as much as what you would think, right? If you have custom instructions, for instance, in Intel or any other x86 or ARM64 architecture, that takes a while to be moved over to RISC-V, right? We may not have corresponding instructions, or we need to rewrite that assembly code. But these are the areas like web servers, caching servers, or even databases to a lot of extent, right? Those can be easily moved from one architecture to the other. So these are the areas where we see that RISC-V can be deployed in a short-term manner versus taking a long time for deployment. Yeah.
Wonderful. I'll ask one more question in this session. We'll try and make this one a little bit more rapid, and then we'll open up for Q&A. So this is the superpower question. If you had one superpower, I describe it as Luke's wish. Luke Skywalker in the Star Wars movies, for those of you who know the Star Wars movies, in the first one asked for, there was no hope for him unless someone could alter time, speed up the harvest, or teleport me off this rock. So if you had one wish to help the RISC-V ecosystem move forward in a scalable way, what would that be? You want to start first?
Sure. I think I've only got one answer to that. Get as many developer platforms out as possible, right? The problem with new ISA is that people can't use it. It's not available, right? Emulators do not cut it, right? Is there anything I could have changed? I would have gotten massive amounts of developer platforms out, and then in little format, like Arduino kind of things.
Okay, developer platforms.
I'm going to go next.
I was going to add.
I think we need to speed the harvest. We're at an inflection point as an ecosystem. Everything is already ready to build. We just need to accelerate now, get more devices out there, and start that spinning wheel.
Steve?
Developer hardware, absolutely. Test suites on that developer hardware to make sure that those developer hardware adheres to standards. Definition of hardware configurations for different environments. So for instance, if you're building a data center server and you might want to see virtualization supported on that, that your minimum list of hardware has things like an IO MMU associated with it. Those are all up there, but I couldn't agree more about the performance of the hardware. If I'm controversial, I'd say that from a performance point of view, we're bumping along just below the performance level of a Raspberry Pi 4. That's kind of where we are at the moment.
Oof.
That's not going to buy us entry into any markets that are looking for significant HPC, except when we multiply out the number of units that we've got. But that's more and not faster.
Kumar?
Sure. I think I would like to add on to what both Steve and Leendert said here. So platforms are, I think, the most important things to have. And in addition to just platforms, I would say high-performance, compatible platforms. What I mean by that is platforms that are compatible to the latest specifications that have been frozen by RISC-V. To take certain examples, H extension, right, for hypervisor support. Make platforms with that available. AIA support for interrupt controllers. It's important to have that as a standard supported interrupt controller. Right, so that's what I mean by compatible hardware. And we saw Sci-Fi announcing the Horse Creek platform with Intel this morning, right? Those are the kinds of platforms should be widely available for the ecosystem. It should be available for people to buy easily, right? So the more people get access to easily available hardware, the next level of the software ecosystem, which includes independent BIOS vendors, ISVs, OSVs, all of those guys can build their software stacks on top of this kind of hardware, right? So it's important to have hardware. And then lastly, I would like to add is even production commercially supported distros, which could be Linux distros on the software side or even other OS vendors, right? Having that available would be the next thing that we should have, yeah.
So before I give Makeljana the final word on this section, do we have microphones out for the audience here? We need to use these? Okay. So let's give away a couple of those, and we'll pass around one to borrow these from this guy. Getting ready for the next section. Forgive me, Makeljana.
No problem.
Go ahead.
So I have a short-term, more pragmatic view, and if I would have a spell cast, would be for everybody to get on the same page in solving the challenges that are keeping the ecosystem currently holding back, and then just start moving product.
So with that, let's open the floor for questions. Do we have any? Yep. Okay.
So I'm going to make an assertion and then ask a question on top of it.
Okay.
The assertion is that what's cool about RISC-V is we can innovate. What's not cool about RISC-V is we want to keep things stable. So we have a tension there, right?
Yeah, I
Yay,
think
we
it's
can
a natural
change,
system.
please don't change.
Yep.
So is that because software being so sensitive to the ISA, kind of a hardware API, if you will, is our ISA too low level? If we up-leveled the ISA in some way so we could innovate under the hood without changing the ISA, would that give us anything? And is that even possible?
That's an interesting question. Anyone want to take a shot at it?
So it sounds like what you're proposing is microcode, which is what x86 uses, right? I mean, this comes down to the RISC philosophy, right? It's very basic instructions. It's a limited set of instructions. So in that sense, yeah, it's an architecture choice that was made, right? And out of that simplicity, you can build high-performance processors. But going a little bit further on your question, I think that the challenge is, you're absolutely right. You've got this tension between ultimate flexibility, right, with all the extensions, to like, no, on the software side, you really want to have stability because you want to preserve your investments that you have made, right? So that's the real challenge that's going on. I think there is extensions possible in certain parts, right? So there is actually a fair amount of stuff that is hidden under plugins or extensions and software layers. So the core of it is the same, right? But you have, for example, instructions to NQ and DQ packets to an accelerator, right? Those you can hide under a plugin, right? So I think those kinds of things you can do, and you can even do them in a software architecture. But things like memory order, atomic semantics, all that kind of stuff you need to lock down right from the start, because it's hard to get it. Well, first of all, it's difficult to get it right. It's hard to change it once there is a lot of software out there that works around all those quirks. And so I think the core of it, you want to keep stable. Then other kind of things where you've got some unique differentiation, and I think it's going to be around, you got some AI stuff that's very special to you, right? But that's all hidden under libraries that you provide as a vendor, right? So it's not really visible to the software stack. But as soon as you start mucking around with branches and other kinds of stuff that impacts compilers, then I think you're off on the wrong track, and it's going to be really hard to support that. So.
And I think what you might be advocating is a wider version of what I think of as the benefit of web ASM, where essentially you're dealing with a number of binaries that have been generated for a fictitious instruction set, and every time it's executed, it's being interpreted to run on whatever the underlying instruction set is. But goodness, I think we should be past the point now of worrying about byte order and stuff like that.
Yeah, so I would add to this, when you're talking about changing the ISA is very far removed from the application and the end users, right? So you got the ISA, then you got the microarchitectures, then you got the silicon. And what we see as a problem as end user and application is the chiasm is between the ISA and the silicon, not necessarily between the silicon and the application, because it takes a lot of time to build silicon, produce, and release it on the shelves. We in the software community can adapt to that very quickly. But building silicon when the ISA is constantly evolving is very difficult. And that's the problem.
Yeah, I want to talk about biology for a minute. In the evolution of systems, in biological ecosystems, any difference that's created that doesn't help you survive is killed quickly. So what happens is biology creates mutations all over the place. And what RISC-V is a biological system for creating mutations. And what's going to happen is some of those mutations will die. Good. Some of them will thrive and create focused differentiation in markets where they truly matter. So I'm a strong proponent of the flexibility of RISC-V. I want to ban the word fragmentation. Right? I want to ban the word because it misses the point. The point is focused differentiation. And when you look at markets and the needs of those markets and ask what's the differentiation those markets need, you wind up identifying those evolutionary differences that are going to succeed and get leveraged on in the future. So I think the question's an important question. And I think what's going to happen is as the ecosystem evolves, we're going to pick those things, and the world's going to pick those things by natural selection. Those things that aren't selected are going to die. And the ones that have enough mass behind them, the software ecosystem like these guys is going to come in behind it and really leverage them further out. So this is I think, the great challenge of RISC-V right now is that we don't have enough critical mass to identify which ones are going to evolve and which ones are going to die.
But let me ask another question on top of your question, sir. What's the most important thing to the RISC-V community at the moment? Is it to have the most elegant, perfect instruction set architecture and software environment sitting on top of it? Or is it a commercial success?
And if you asked 100 people in this room, you'd probably get 3 different answers given that you had a binary choice there. One of those 2 or something else. And I think that's one of the real problems, which is it's not a monolithic community yet, and it won't be. So that's a great question. All right, let's try and get a couple more questions in here. Person in the back standing up with their hands raised. Any questions online? Oh, that's terrible. Every open source RISC-V should be upstreamed first, okay?
So I don't want to put anyone on the spot, but just example of Ventana chose the RISC-V as their core for the CPU designs, and Qualcomm has chosen ARM as their mainline product solutions. So based on your experience, what made the Ventana to choose RISC-V versus the ARM, where probably there is a stability versus the flexibility? And same question for the Qualcomm, why the RISC-V would not be the contender at this point versus the ARM? So what are your choices and how that justified for your cooperation?
Okay.
I can take the Ventana question first, and then later you can take the Qualcomm question. Okay. Yeah, so from our perspective, right, so from the Ventana side, the choice of RISC-V was pretty clear, primarily because of 3 reasons, right? First was the ability it's an open ISA, right? So it blends to the ability of being able to innovate. And innovation is key. Being able to add custom instructions and custom extensions is absolutely critical. So that is kind of the second reason. And thirdly, the large ecosystem that RISC-V has, right? Something that's different from ARM. So why it's different is because we felt that with ARM, it's just the silicon vendors of certain member companies that are driving the ecosystem. With RISC-V, there are, as I mentioned, over 3,000 members, over 10,000 software engineers working on the software ecosystem, right? So it's a very large community of ecosystem of engineers that are working on the ecosystem. So it was pretty clear, right? With these advantages that RISC-V has, that was the default architecture of choice for Ventana.
So to expand on what Kumar said, right, it's clearly that rate of innovation, right, that is quite interesting to us, and that's something that we're very excited about. The other one, to be honest, is cost, right? And obviously, as you see, I can't comment on it, but we're obviously being sued right now. But a big element of that is cost, right? And that's one of our interests, other interest of RISC-V, right? And of course, we're very interested in making sure that this is a community effort, right? That there's not a single entity that holds or controls RISC-V. I think it's very important that this ISA is open and stays open, right? And Qualcomm will support it as one of the many contributors who are in this room.
So let me add something controversial to that. As I look through all the different RISC-V implementations that I see out on the market, 80% of them are closed.
You want to add anything to this? Okay. Any other questions?
No, I can add to that.
Okay.
I think, well, no, but you're right.
Controversial,
Right?
let's
So
go.
what is open is the ISA, but what is closed is the implementation, right? And that is perfectly fine, right? That's how you do business. And by the way, there are plenty of open source RISC-V cores as well. So
The microarchitecture is closed source, right? The ISA is open source.
Okay. Any other questions in the room? Yep. Right there.
Just to reflect back that last point, in the other ISAs, everything's closed. So we're at least moving in the right direction. And I think I'd be interested in what the panel thinks, expanding on that, that there are a lot of RISC-V cores that it would be good if everyone rallied around a single open source. If you've got a junk microcontroller, why wouldn't everyone build the same open source one rather than having to license and fix the bugs in that one and fix the bugs in that one and work around the bugs in the third one? Whereas if we did for some of these processes where we don't need to innovate, maybe we should all be rallying around some of the open source.
The Highlander proposition, there shall be only one.
So there's the superpower that the community owns.
You want to say that to the mic?
Sorry, what I said was what the gentleman's just articulated. That's the superpower that the community owns. We can't drive that. The community needs to decide we're going to concentrate on these cores and enhance those. Let's get all the bugs out of that.
And that's the hidden hand of natural selection at work right there.
Yes, you're competing with very large, sizable, established companies that have already had a huge amount of success. Now, from an application standpoint, we don't care what's open or closed. We don't care if it's open or closed. What we want is we want our customers to have the maximum amount of opportunities to innovate, accelerate innovation, develop new devices, and connect to the cloud. So if the community could get together with an open source microarchitecture that everybody was using, it would make the whole software ecosystem so much easier to scale.
Makeljana, you want to, how would it help VRULL?
I want to add
just a second. Let me get her in one more time. How would it help VRULL if there was only one? If there was only one.
Well, I mean, I want to start with saying that RISC-V is not the only ecosystem we're working on. So we also work in ARM. We provide services for companies in ARM as well. But I guess okay, I'm stuck.
Okay. So I wanted to add to that a little bit. So the model you're proposing is basically that of Linux, right? Where there is an open source version of, let's say, an MCU, a RISC-V MCU. But that doesn't obviate the need of companies around that to support that, right? Steve next to me has built a whole business around this, right? Where the core is open source, but as a company, you still want liability protection, you want support, right? Basically, you want a throat to choke when something is wrong. And that's not much harder to do in the open source community. So the companies will not go away, right? But yeah, certainly for certain spaces, like an MCU, yeah, I could imagine that you've got one standard or an open implementation because it's relatively straightforward. But again, companies build other support around it, right? So it's not just the microcontroller they're building, not just the processor, it's other IP blocks, how it interfaces to other things, how it is tested, how the quality is driven for it. So companies still provide value.
Okay, other questions? Okay, I'll let the panel have final words. Anything you want to add to this august body of people out here?
Okay, from our side, I think we are firmly believers of RISC-V, as we said. We are excited to launch our first product that we did this morning. It's the Ventana Veyron V1, and we would continue to innovate. It's a high-performance design using the chiplet architecture. So we are happy to have announced that. We see a very bright future for RISC-V for the reasons we just spoke today, and we are pretty excited to be part of the overall community, and we want to drive this ecosystem going forward.
So yes, we're quite excited about RISC-V as well and the opportunities that it offers. I think we're also looking at the challenges, and we'd like to work with the community to address those. I mean, things like avoid needless differentiation, right? We've seen this in other ecosystems. I think that's one that we need to curtail. And to your point, there is a tension, right? So we need to work through that. The other one is adopt existing standards, right? When someone mentioned to me there was a server company somewhere that showed booting up with U-boot, and I'm like, oh God, there we go again, right? We did that 8 years ago, and it was not a success. So those kinds of things, adopt standards in the areas that are applicable, right? I'm not saying drive one particular thing everywhere, but adopt it there. And so again, you want to reduce the friction of adoption. That's what this is all about. And then the other one, the profiles thing, I think is a very good movement on the RISC-V part, because that's going to provide that ISA stability that software companies can depend on. And again, let's get this first one right. So the RV22 and 23 ones right, because these things are going to be with us for a long, long time to come.
Completely agreed on the with us for a long, long time. These things have got a very long tail. So what I would say is that Red Hat are cautiously optimistic about the future for RISC-V, and the caution really comes from the concern that the degree of openness and the degree of innovation that the RISC-V ISA brings with it will generate constant fragmentation. And to be honest, it's the operating system where all of that fragmentation comes to live, and it forms a barrier to plug and play kind of it just works straight out of the box software delivery. So cautiously optimistic.
So I will echo what Steve just said. We're very excited about the prospect of RISC-V. We see a lot of value. We love the silicon ISA revolution, but we're cautious too. And as an IoT lead at AWS, I have to make decision as to whether we develop our application and software for ARM in IoT or ARM and RISC-V. And so I need the community to help me, give me the data so that I can say, look, it is worthwhile for my team to delay the launch of a product by 3 months because we're going to make sure it works for both ARM and RISC-V. Or can we just, for now, in the next 2 years, ignore RISC-V and focus solely on ARM because that's where we're going to make money and that's where we're going to deploy. So those are the challenges that my team and I have to face. And this is the reason I'm here, to get answers and feedback as to, no, please, we have momentum, we can get that flywheel running, and you should absolutely make sure that all of your software works on both architectures at the same time.
I'd like to close by saying that yesterday there was a similar Q&A session, and a lot of people tried to highlight the fact that the openness of RISC-V is one of the values that drives the community and the ecosystem. And absolutely, it is very important, and no one it's no doubt no one can argue with that. However, we just still have to not ignore the fact that openness only, it's not enough. If we are trying to make it happen, if we're trying to move product, we need to make sure that it's also ready. I'm talking about the software ecosystem. Yes.
Super. Well, I want to thank you guys all. It's been terrific. I want to add one comment from my own background, which is I've been at Intel 6 months now. I came over from ARM, and 9 years before that, I went from Intel to ARM. And what I'm excited about, I came to Intel back to help Intel ramp up its capability to support ISAs that aren't x86 in applications that are in markets that Intel's traditionally served, with a wide range of system configurations that we're going to support. Pat Gelsinger has called this concept Open System Foundry. And a central part of Open System Foundry is the respect for emerging ISAs and emerging applications. And this is why I'm putting my effort in RISC-V now. There's return for that investment. And that return is growing this ecosystem around us, creating new commercialization opportunities, and building out kind of a better technology world for everybody to stand on as things go forward. So I'm excited to be here. This is my first RISC-V International Summit. I want to thank you guys all for being a great audience, and thanks, panelists, for doing a super job. Thank you.